Okay, now that we have attack collision down pat and ready to rock, why don't we look at how we can control the camera and keep the player within the bounds of the camera. Right now, on our Gambit controller, we just have a simple X-Min, X-Max, Z-Min, Z-Max clamp system set up. Remember how we did that with our space shooter? What we're going to do now is we're going to have to make a way to update the X, Min, and Max, because when we're walking through our stage, we're going to have to be able to walk farther than 5 units to the right, because we're going to be way down here. So not only will our camera follow our player whenever it's time to progress further in the stage to the right, but our camera is also going to keep our players within the bounds of the screen. Why don't we just go ahead and select our Sentinel prefab, hit apply for old time's sake to update everything we've done to the prefab, and just get him out of the scene for now. All right. What we're going to do now is we're going to have to create a new empty game object, and this is going to be our camera controller. And we're going to reset all its values. And why don't we go ahead and reset Gambit back to the center of the screen as well. And then we'll just kind of zoom in like so. Now, the first thing we're going to do with our new camera controller is we're going to nest our current camera under our new camera controller game object. And you'll see that, let me go ahead and press play, and let's talk about perspective and how it relates to side scrollers and in this case beat 'em ups. All right, so let's say I'm at the edge of the screen here, all right, and let's say that I'm being bound and I can't go any more to the left. If I press up, look what happens. I don't go up the side of the screen like in old beat 'em ups. I pretty much go almost back at an angle because perspective, right? So there's going to be two ways we're going to combat that kind of weirdness. First of all, I think we can all can agree that my character looks really tiny when he gets that far back into the distance. But yet I still want to have enough playing field. I don't want to have to constrain him to not much playing field by zooming my camera closer, because I could do this for sure, but maybe there's less camera field there. So what we're gonna have to do now is we're gonna have to figure out how we can kind of cut down on that perspective skewing of things, get it closer to what the old isometric flat beat 'em ups used to look like, while still have some of the benefits, of 3D, such as, perspective is actually not that bad in this case as well. It gives it that nice 3D sheen. So I'm going to select my camera and I'm going to go to field of view and I'm going to set that to 30. And I'm going to adjust it like so. Notice that as I pull my camera back, the character doesn't seem to be that small anymore. And at this point, it's just your personal preference on how far back you want the camera to be. You can test it out by pressing play. So you can have something like, let's see, I want to put control gamma to see. If you want, it just depends on how big you want your playfield to be. So what we're going to do now that we're really focusing on camera is we're going to see how far back in the Z-axis Gambit can go. And I'm going to kind of butt up my attack box, or my hit box next to that building. And it looks like we're at 1.3. So my Z max is going to be 1.3. I'm going to still update my Z and min and max over here. And with my new camera position, it looks like I can go as far down as negative 1.5. So I'm going to do negative 1.5. So now when we press play, Gambit can't go off screen. And he can only go so far back where he's not hitting any buildings or anything. And I think that's plenty of screen space. I mean, it takes a little bit for him to go up and down the full yield, but we're coming into an issue in that he can go off screen. And since our X is going to constantly be updated as our player and camera go down the stage, like so, we're going to have to figure out some way where we can keep a constant way to keep our player in bounds of the screen. So rather than use our X-min and X-max, I'm just going to go ahead and set these to really tall values. We're actually going to put in invisible walls that move with our camera. In order to do this just right, we're going to use some placeholder spheres that we're going to position on the edges of our screen. I'm going to get them just small enough. Get them down the little thing right on the ground. And I'm going to position my spheres in my scene view according to what they look like in my game view. So having both screens up will be necessary at this point. We're just trying to get to the very accurate reading on what's going on here. And how far back should they be? Well, why don't we look at our Z-min and Z-max. So this front sphere right here should be about negative 1.5 in the front, and this second sphere should be about 1.3 in the back. I think this was our boundaries. At 1.3 for max, negative 1.5 for min. So now that I have the correct Z spacing, I can get it right on the edge of that screen right there. And now we have, excuse me, I might be coming down with something. We have 2 points that we can now line up a wall between and get the exact value that we need. So we're going to do the same thing for the other side. I'm just going to duplicate and grab this last sphere. I guess it's the second one. Like so. So now that we have our sphere set up, we're going to create a new 3D object. We're going to create some cubes. And these cubes are going to serve as our boundary walls. So we're going to scale them up and flatten them out, elongate them. Then we're going to come over here and rotate them like so. Go ahead and turn the mesh renderer off. You can still see what they're up to with our collision box that's attached. And I'm going to use the base of this wireframe collision box just to nest those 2 spheres right inside. And if it helps you, you can also go switch between global and local. So now the arrows change according to their local position of the box or the global positioning of the world. This will also help you, going in local will also help you scale it just so. And then push and shove it just so too. All right, that looks good. All right. And if we turn on our mesh renderer, we can see our wall kind of at work inside of our game. You can even adjust it based on the perspective. Right now I'm basing it on the line right here in my game view to get it really flush like so. And why don't we call this cube boundary left, something like that. And I'm just going to duplicate that. We're going to call this boundary right. And I'm going to, instead of having to reposition it, I'm going to say positive 3.72 over here in my inspector, and then positive 2.4 or 24.9 in my rotation. And you can see that it pretty much lines up correctly. All right. So why don't we give it a test according to where my camera is. There we go. My player can't walk off screen. There's going to be a few more considerations we have to take for these walls too. First of being, yeah, probably shouldn't have them rendered. And we can delete these spheres now as our placeholders for setting up our walls just right. The next thing we're going to have to figure out is, okay, if these walls are physical boundaries, are our enemies or are any other collidable objects in the world going to collide with them? And if so, that's going to be a problem. Our enemy won't be able to walk, off screen or get knocked off screen. We want our enemies to walk off screen. That's kind of one of the staples of a beat 'em up is enemies being able to be knocked off screen or come from off screen or be hit from off screen. So we only want our walls right here to be affected by the player. So what we're going to do is we're going to use layers, and we're going to use our project settings, physics, and here's a little matrix we have right here. This directly relates to what layers interact with each other in a collision and based environment. So we should have a layer. If we go down to layers, you should have a layer for your level meshes. And if not, we're going to go ahead and go to edit layers. And we're going to go ahead, and if you don't have a level meshes, or you can call it environment meshes, we're also going to make a player layer and a boundary level layer, rather, or maybe player boundary, like so. And then we're just going to apply. First of all, if my level doesn't have a level, I'm going to go ahead and set it to level meshes, and yes, children only. Now I can lock down my level, so I can't select it. I think I had that set up for you guys. Now I'm going to select my two boundary pieces that I just made, and I'm going to set it to player boundary. And I'm going to take Gambit, and I'm going to set it to player boundary, yes, all children. And we're going to update that prefab by pressing apply. Now we're going to go to edit, project settings, physics, and now we have some new entries in our collision matrix. What we're going to see is our player boundary down here on the top. We're going to uncheck everything below it except player. Now anything in my player boundary layer will only affect things checked under the player layer. And the only thing in the player layer is my Gambit. So now these walls will not affect anything that's not Gambit or in my player layer. And we're just going to nest that under my camera controller. Now, when my camera moves, you can see in my scene view that my wireframe boundaries move with me. All right, so we're getting there. What we need to do now is we need to actually make a script for our camera controller to base its behavior off of. So I'm going to go to my scripts folder. I'm going to create a C# script. I'm going to call this camera controller. And this is going to be an easy bit of code. We might introduce a new vector3 kind of function to you guys, but when you see it in action, it'll make perfect sense. And I'm just going to flop this new script right on top of my camera controller game object here. All right. So the goal of our camera controller is to follow the player whenever there's no more enemies on screen and we have to go right. All right. I don't know if you guys have ever played a beat 'em up, but the basic level progression of a beat 'em up is you start out in an area, you beat up all the enemies, defeat them all. Then a big arrow says go right, and you walk to the right until you get to the next area where the enemies spawn. Then the camera stops in place, and you can't move to the right anymore until all these enemies are beat up. You beat them up, then you keep going right. You stop, kill them all, go right, stop, kill them all, and go right, stop, kill them all. Basic stuff. I'm going to go ahead and set this back to 0 in the X direction. So we need to create a camera that follows that kind of logic. So we need to be able to tell the camera when to follow the player and when not to follow the player. Basically, when to follow the player or stay in place so the player can beat up everybody on the screen. So we're going to go ahead and bring up my camera controller script here. let just mono-develop load up. So I've already said one bit of information that'll be key here, and then that we'll need some kind of flag, Boolean flag, that is, to tell whether or not we should be following the player. So out of the bat, we have a variable, a public variable is following, and this will be what tells the player, or tells the camera what it should be doing. And then we're going to make a void awake function. And what we need to do now is we need to find our player target. Well, I guess we need to have another variable, and we're going to make this one private, and we're going to call it player target. And whenever the game starts in void awake, player target is going to equal to game object dot find objects with tag player. Nothing new there. So after this line of code, we now have the ability to go and find exactly where our player is. So in our void update, the obvious thing would be to do is to say transform dot position equals new vector 3, and then say something like player target dot transform dot position. Because when we're updating our transform position, we have to make a brand new vector 3 or a brand new XYZ coordinate, and then we'll just look at our player targets transform dot position, and that gives us that coordinate. All right. But first, we need to say if is following equals true. We only want the camera to update its position whenever following is set to active. All right, so why don't we see what happens here with this bit of code. All right, we got to shore up our vector 3 right here. So I guess this bit of code's not liking that. So why don't we just do a temporary vector 3 variable and say something like vector 3 dot temp player position equals player target dot transform dot position. Maybe this will work. And then we'll substitute that with temp player position. Still not liking that. Yeah, I'm back. I guess the new vector 3 was looking for 3 floats. So I just got away by doing this by making a this is all going to be throwaway code. I'm just going to make a point real quick that we can't just set the transform position of the camera equal to the player's position in the X, Y, and Z, because it'll make the camera snap to the player here. So if we're in our game here, I'm going to select my camera controller. Right now, we're not following. But as soon as I press this check mark, look at the camera. We're following the player, but it's just snapping and getting way off track here. So this is not the behavior that we need. Look, even the camera's like going in and out of the scene, totally messing up our boundaries that we had set up over here. So instead of just matching the camera to our player's position, let's get rid of some of that code that I had set up. Instead of doing that, we're going to use a new vector3.lerp function that smoothly transitions the camera to another point, and then we'll start following that point. So what we need to do is we need to make sure that we need to find only the X position of our player here. We don't want the Lerp to just go straight to the player. We only want it to go left and right. So we're only going to find a vector that updates on the X-axis. So we'll just make a private vector 3 variable, and this time this is for real. We'll call this player X position, or pos for short. And in our update, we're going to update our player X pos vector 3. We're going to set it to new vector 3, and we're going to say we only want to update our X we're going to say player target dot transform dot position and the X of our position here. Then we're just going to say 0.f, 0.0f, and call it a day. In fact, I'll go ahead and make this public so you guys can see what's going on with this variable now. So this little bit of line of code, we now have a new player X position, and notice how it only updates in the X. No matter if my player walks up, down in the Z, we're only getting the X change right here. We're only getting a vector that updates in our X direction. So when we transition our camera to our player, it's going to be based on this vector, and it won't go in the Z axis at all. It'll only go left and right in the X now. So to see how the lerp works, so following is set to true, we're going to set our transform dot position of our current game object, which is our camera controller. So this object's position equals vector 3 dot lerp, and lerp is a linear interpolation, meaning it starts from one point and then gradually goes to the next point and has a nice little soft fade in, fade out kind of motion. We're going to say that it needs to know where we are now, which is, again, transform dot position. That's the first argument it takes. See the little yellow box right here? It has a vector 3 from where are we going, a vector 3 to we're going, and a float, how fast or how much time it takes or anything like that. That's going to be our speed of our interpolation. And we're going to go to player X pause and camera speed. We don't have a camera speed. Better make one. We're just going to make a public float up there. And I'm going to go ahead and make this vector 3 player X pause private because we don't use it that much. I really just want it working behind the scenes. I'll hit Control S. All right. So now we have an is following and camera speed. And we're going to set our camera speed to be really low, like 0.01. All right. So I'm going to press play. And I'm going to walk maybe up here. We've just defeated all the enemies. So is following is set to true. See how our camera goes to the center of our player? Now it follows us. And you might want to experiment with the speed of the camera just a little bit. The only thing is, you're trying to balance the snap. You want the snap to be more gradual. So 0.05 maybe that's a little bit better. 0.05. You really want that snap to the player after you defeat all the enemies to be not so harsh. There you go. Notice how we keep the same Z direction. The camera only updates left to right. We just defeated all the enemies. It's following us at the true. And I still think that's a little jarring. That's why I like doing 0.01. I want a nice smooth transition. Like so. So whenever we defeat all the enemies, I don't know, maybe let's play around with 0.02. So we walk up here, we defeated all the enemies. It's following, set to true. There we go, that's a little bit nicer. And it looks like our camera is staying current with our player real quick. That's good. All right, so half the battle's done. Now we need to be able to tell the camera when to stop following our player. We'll get to the logic of when all the enemies are done, then we'll trigger an is following check later into the videos. Right now, why don't we go ahead and set it to where we can set is following defaults. And the way I achieved this is I made one more cube, and I called this camera midpoint. And I made a tag just for it. I called this camera midpoint. Pretty unique name. And I set my camera midpoint tag, and then basically I just made a little and I turned the box collider to trigger, and then I made it just like a little almost little wall here right in the middle of my playing field. Just kind of floated up right here. And this wall is going to check. It's going to move with our camera here. And it's going to try to collide with different markers we're going to set up. And whenever this midpoint collides with a marker, your camera is going to stop following the player. So we already got it kind of set up. Our box collider is set to trigger. Let's turn our mesh renderer off. Now we need to create our stop point markers. So we're going to create a bunch of little spheres next. I'm going to reset their positions and maybe scale them up, have them floating a little bit. And we're just going to have them floating anywhere we want the camera to stop. Basically, every checkpoint or every battle encounter, we're going to put this little guy. We're going to call it camera stop, parentheses 1. We have to do a few things here. For our colliders to work between our midpoint and our camera stop, we're going to have to give it a rigid body. But our rigid body is not going to do anything. We just need to have it for our collisions to work. And then we're going to make one more script. It's going to be another short one. We're going to call it camera stopper or camera stop, whatever syntax you want to use. And it's just going to be a simple on trigger enter bit of code. So let me bring up camera stopper. We're not going to need update or start. We're just going to live in void on trigger enter, and then typecast a other collider so we know what we're hitting. And then we're going to say other object. I guess we need to make another object. It's going to be a little bit tricky. We have to do that parent trick. We have to say public game object other object because we're colliding with our midpoint on our camera. But what we need to do is we need to look at the parent object, which is our camera controller, because we need to get at that is following flag. So even though we're colliding with the camera midpoint, we need to actually adjust the scripts on that parent object camera controller. So other object will equal other.transform.parent.game object. And then other object, now that we have our camera controller set, we're going to get to that get component. We're going to get to the camera controller now. Dot is following equals false. And then after we're done setting all the is following flags, we're going to just deactivate this object. Dot set active false. That way, once we collide with it, basically the little camera stopper just goes away, so we don't end up keep colliding with it again in the future. So it's pretty easy stuff. We look what we collide with here, and then we find the parent object of it. So we look that we collide with camera midpoint. Oh, I forgot one more bit of code. We need to have a other.tag. We need to have a check to see if we've actually collided with a camera midpoint. Now my formatting's all out of whack, but never fear, I'll just highlight it all and press tab, and it's good to go now. Set up my brackets, and then I'm going to do an else return. For all other tags, we're just going to return and do nothing. All right, great. So now, if the other tag that we collide with right here, if that other tag equals camera midpoint, which it does, then we're going to have this other object public variable that we declared up here, and we're going to initialize it to say, okay, the other camera midpoint object, its parent is what we want to set other object to. And then once we have a way to access our parent object, our camera controller here, we can get at the camera controller component and set is following, that important flag we were toggling back and forth to get the camera to follow our player. We can now set it to false, and then we're just going to deactivate our camera stopper. And if anything else, if any of the other tags do not equal camera midpoint, we're just going to back out of the script. That's probably redundant, but I put it in anyway. All right, so that's great. So now we can position our spheres like so. I'll put a few in just to demonstrate. And you may want to kind of get them together. And I want to put them right under my camera controller like so. You could make your own empty game object to kind of tidy up the outliner if you wanted to for that. But in this case, I just want to demonstrate what's going on. So this is the beginning of the level. I've just beat up all the enemies. It's following, it's set to true. Now the camera's following me. And you can actually look at my scene view here. There's my midpoint stopper here. And there's my little checkpoint sphere that we've made. Now our camera stops. And we're ready to beat up all these enemies. All the enemies are dead. Now it's following the set back to true. And we'll get another perspective of this in our scene view. See what's going on. So we're walking along to the next battle encounter. We see this little sphere here. Now we're ready to start beating up these guys. And notice how I'm not destroying them. I'm just deactivating them. They still exist in my scene. They just are not active at all. And I've just beat up all the enemies there. And we're going to do one more checkpoint here. You can see right here I have one more little sphere. And I'm just walking, I'm going right. Boom. Now I got to beat up all these enemies. All right. So that's the camera system in a nutshell. Not too bad. The trickiest part was just setting up the different things inside of the actual project file and maybe learning how to do that boundary matrix. Remember the project settings, physics. Remember this layer collision matrix. It's more of a, I guess it's a matrix. It's got X, Y. I don't know. It's not just a simple list. It's got more. A matrix is just a three-dimensional array, basically. You guys know what arrays are. It's also where machines enslave you and feed off your bioelectric, whatever. That was a stupid plot. So with this matrix setup, we only collide with our player here, so we don't really mess with too much other stuff. That might have been the newest thing. And also our Lerp here, going from one going from one vector position to another vector position at a slow speed, and linear interpolation does the transition smoothly for you. I couldn't imagine doing that without that function. That'd be so much math. All right, guys. So that's your camera. Next lesson, we're going to probably tackle some UI stuff, and then we're going to get into I don't know, maybe try to figure out how we can get that is following flag to check true once we kill all the enemies on the screen. Maybe use an array, but we'll also have to figure out how we instantiate enemies. So maybe have another little boundary box in our camera controller, like way out here, and as it activates certain spawn points, this little boundary box will say instantiate enemy or activate enemy. So off screen, our enemies aren't activated until this little trigger right here says, okay, you're good to go, and they spawn in off screen, and it looks like they're waiting for us. All right, so I'll see you guys next video.